on your part there, try to do that one alone and give me your answer, and then I'll be showing you the way how to get the LCM in there. Okay, I guess you are referring to the number only, the LCM of the numbers. It's 80, but we have their different variables. Yes.
80,
Very good. That's the
80
exact
a
LCM
squared
in
b
there.
cubed and c.
Okay. Now for 16, 5, and 20 in there, what I presented a while ago was listing down method or the multiple listing down. So we are going to do the second method here in finding your LCM for the numbers there. Because for variables, we don't have really a problem with variables. We're just collecting all the variables in there. So considering numbers, we have 16, and we have the number 5, and then the number 20 in there. So the next method here is what we call as the prime factorization. So prime factorization method, this can also be done when you are looking for um, GCF, but that is different from how we are going to look for the LCM. Now, how do we find the prime factorization, or what do we mean by prime factorization here? When we say prime, they are the numbers in which we are multiplying that number by 1 or same number by 1. So those are, if their only factors are the number itself and 1, so that is prime. Now, for factorization from the word factor, so they are now the numbers in which you will be multiplying to come up with a number. So what we are literally looking for here are factors that are all prime. Now, we can use prime factorization 3 here to look for the prime numbers. We start with 16. 16 has factors of 8 and 2. Sorry, on that one. 8 and 2, or you can have there 4 and 4. That is the same. So since 2 is prime, so we stop that there. And then 8 is not, we branch that out. So we have 4 times 2 for this. 2 is prime. We branch out 4. So 2 and 2 there. So collecting all the prime numbers in there, so we've got 2 there. How many 2's are there? We've got 1, 2, 3, 4. So we have here an exponent, which is 4, to indicate that there are 4 2's on your 16. Now, since 5 is already prime, so we do not branch it out, but we simply copy it there. And 20 is not prime, so we branch out. This can be 4 and 5. 5 is prime, 4 is not, we branch out. So this is now 2 and 2. 2 is prime. So we can now write our prime factors. We have 2 squared because there are two 2's in there. So we have 2 squared. And then multiply that to your 5. Now looking for the LCM on those numbers, we have the LCM for the numbers there is simply collecting every factors present in there on those numbers. We start with 16, factor there is 2, the prime factor there is 2. And looking at your 5, we don't have 2 in there, so 20 we have 2. But your 2 there got 2 as your exponent, but this one is 4. So we simply copy our exponent which is bigger. So that is 4. Now next we go to the next prime which is 5. We also have 5 here, so we simply copy because they have the same exponent, which is 1. So multiplying that one further, so we have now 2 to the power 4 is 16 times 5, that will be 80. So our LCM now will have 80, and then we are collecting A. A is with 1 as an exponent, and the other one is 2. The other one is 1. So we will be following the 2, which has the highest exponent in there. And then for B, we have 3 on here, and then 2 in there. And we don't have on the 20 AC in there. So we are following the 3 as the highest exponent. And we still have C, so we simply copy. There you go with the LCM, 80A squared B cubed, and then we have a C. Okay, next, we go for that one. What do you think is your LCM?
12
Very
x
good. That
squared
is
y
12x
squared.
squared y squared. So by listing method in there, so you can just simply say 6 has the multiples of 6 and 12 and so on. And then we have the 12, multiple of 12 is 12 and so on. So we found our least common multiple for those numbers. Writing the least common multiple, we've got only 12. And then collecting all the variables, we start with x squared and then y squared. So there you go with the LCM. Next, we go for the binomial. So for binomial or trinomial, you simply have to factor it out and check whether we've got factors that are in common. Because factors with common or in common, we only write that one once only.
X squared minus x minus
X
4.
squared minus x minus 4. Um, you were trying to
No.
collect everything? Yes. So again, you are going to
Yes,
factor it
ma'am.
out, factor all the binomials, and then collect all those factors on it. Okay, factoring this out. So I really wanted everybody to relearn factoring because factoring is really important here in solving rational equations later on. So factoring this one, you've got there x squared. So we start off with x squared in there minus x. And then finding the factor in there is for you to check whether you have their common variables or numbers on it. So checking up, we've got x squared in here, and this one is x. So common here is x, so we let that out. So finding for the rest of the factor there is to simply divide your terms in there by what you have let out. So x squared now will be divided by x, that is x. And negative x divided by x, that will be negative 1 in there. So your factor for x squared minus x is simply x times x minus 1. Now moving on for the next binomial, we have that one as x squared minus 4 Checking up each term, we don't have common factor. But if we try to look at that one, we've got perfect square on the first term, perfect square on the second term, and operation is minus in there. So if that's the case, we are going to do the difference of two perfect square binomials. And factoring that one, we have here two factors. This one will be a minus and this one will be a plus. We are getting the root of each term. So root of x squared is x. Root of 4 will be 2. So that means we have that one as your factors. Now, checking up all the factors, we cannot see anything in common. So if you cannot see anything in common in there, you just have to list it down. So just simply copying that down there. Or you can just go back to the original one and have that one as the LCM. So do not multiply that. Do not bother multiplying that one because you will be having trouble later on when we are dealing with rational equations and solving for the variable of x or value of the variable. So do not multiply it back. Just have it that way. Okay? So next we go for this one. This is now trinomial. And again, for binomial and trinomial, you need to check if you can factor